Alright, so this is a red oak. The bark is kind of thick grooved, splitting. I just know it's been here forever. This is the largest red oak on my property here, and what we're going to do today is we're going to try to guess the age of this tree. So to do that, you need yourself a rope or a flexible tape measure, measuring tape, and you want to measure the circumference of the tree 4.5 feet above the ground. That's known as the average breast height of a tree. So once you wrap your tree around, take your rope and get the length of it. So I'm going to try that now. Hold on. Looks like the rope I picked was just long enough to fit around the circumference of the tree. So I'm going to hold right at this knot and this part right here, and I'm just going to go measure from the knot to where my hand is using a tape measure. Okay, I got my rope lined up and measured out with the tape measure. Looks like I got about 79 inches. Okay, so we've got the assignment opened up here. This is the aging your trees assignment. You can see the northern red oak there is what I was looking at and measured. That has a scale factor of, or a growth factor, sorry, of 4 here. So what we're going to do now is just apply this property here. So we are going to find the diameter of the tree and then multiply that by the growth factor. So we've got the circumference, and that is equal to the diameter times pi. So my circumference of that tree was 79 inches. So I need to take 79 and divide it by 3.14. And that will give me the diameter. Then I can go ahead and multiply that by that growth factor of 4. Alright, so I grabbed this oak stump out of my fire pit, wood pile, and hadn't split this one yet. Came off the same property, so it should have relatively the same growth rings as the large red oak that you saw. So I just sanded this down, and got a little wet, see if I can count the rings a little bit. We're going to do the same technique with the rope, get a measurement, and we'll compare that and count the years with the rings to see how well that compares with the big tree and the actual growth rate in the formula page. Okay, I got the stump measured out, and it looks to be about 28 inches. All right, so I marked up the growth rings on this little oak stump, and you can see I put a dash for each year, counted, put the 10, 20, 30, 40. Look at 40 through 60. Those were tight, really small. I had to really work hard for those ones. And then it looks all the way up to the outer shell here. I got about 73, not counting the bark. Alrighty. I went and filled in that information on here, and you'll see for the large tree, we had the 79 there, and the circumference, or the diameter, I'm sorry, was 25.2, and then multiplying that by the scale factor predicts that that tree, that large red oak tree, is approximately 100 years old. I would say that's probably pretty accurate, but then again, here's the stump. The stump was 28 inches in circumference, which gives me a diameter of about 8.9 inches, and when I multiply that by the growth factor, I only get 35.6 years old, and clearly that tree, well, we counted what, 73 rings. So why such a huge difference? And well, if I had to speculate, those years where they were really close together, there must have been some severe hindrance on the growth of that tree that prevented it from getting its normal size. So not all the rings were equal. If they were all equal, I'm guessing that circumference would have been a lot larger, and then it would have been pretty close to the actual size.